If you've ever tried to create a character with AI, you know the feeling, right? You've got this perfect vision in your head, you write what you think is a great prompt, and you get something amazing. But then, you try to put that same character in a new scene and poof, they're just gone. Replaced by a total stranger. Well, today, we're gonna fix that. For good.
So let's start with a really simple prompt, a cyberpunk detective with a neon blue visor. And hey, we get this cool-looking character on the right. I like it. The visor's there, the vibe is right on. Okay, so let's try to generate him again, maybe in a different pose or something.
And? Wait a second, who is this guy? The prompt is identical, word for word, but the character is completely different. I mean, sure, the visor is there, but his entire face, his hair, it's all changed. And that, right there, is the problem.
Okay, let's try just one more time. Same prompt, and... Yep, there it is again, a third totally different person. This is what we're talking about with AI forgetfulness. It's like it has no memory. It treats every single generation as a brand new request, which makes building any kind of consistent story basically impossible.
So, this brings us to the big question, doesn't it? How do you fight this digital amnesia? How do you actually get an AI to remember your character, not just for one image, but across an entire project? Well, there is a way, and it's less about writing a magic prompt and a lot more about engineering.
All right, let's dive in. Here's our game plan for today. First, we'll quickly nail down why this consistency problem happens. Then, we'll introduce the visual engineering solution. After that, we get hands-on. We'll write a character's visual DNA, learn to master the scene around them, and finally, bring that character to life with animation. The root of this whole issue is actually pretty simple. Without a really strict set of instructions, an AI image generator treats every single prompt as a totally separate, independent request. It has no idea you want the same detective from 5 minutes ago. It just reads cyberpunk detective and goes, okay, here's a new one, every single time. And this gets way worse when you start adding a new environment. This is something called style drift. Let's say you put your photorealistic character into a scene you've described as woodcut engraving style. The AI gets confused. It tries to make the character fit the world, and in the process, it often changes their core features, completely destroying the consistency you're trying so hard to build.
So how do we fix all this? Well, we have to move past the idea of just writing better prompts. That's not enough. We need a deliberate workflow, a methodical approach. And this is what we call visual engineering. It's about defining and locking in your character's identity so the AI has no choice but to get it right.
I really love how this reframes the whole goal. We're not just describing a character anymore. We are defining its source code. It's a huge shift in thinking. It's like we're treating our character's identity like a piece of software that we have to program with very specific, unchangeable rules.
This quote just hits the nail on the head. You have to start thinking like a developer. Your character description becomes an immutable, and that just means unchangeable, piece of code. Once you've written it, you don't tweak it, you deploy it over and over and over again with perfect precision.
Okay, enough theory. Let's move to our first practical step and actually see how this works. It's time to forge our character's core identity, their visual DNA. This is the foundation that everything else is going to be built on.
Now, this is a two-step process, a real 1-2 punch. First, we define the character's identity using text. That's our seed prompt. Second, we use that text to generate a visual blueprint that teaches the AI its 3D structure. That's our reference sheet. Text first, then geometry.
The seed prompt is basically your character's soul, but in text form. It's a super detailed description that you will use, and this part is absolutely critical. Word for word, every single time. You can't change one adjective, not one comma. This constant repetition creates what's called a semantic anchor, which triggers a process called prompt chaining for identity, forcing the AI to remember the same set of features.
So, once you have your seed prompt locked and loaded, you use NotebookLM's image generation tool, Nano Banana Pro, to create a reference sheet. The prompt is simple: comic book character reference sheet, and then you paste in your seed prompt, showing 6 different views. What this does is it forces the AI to render your character from multiple angles at once, which locks in its geometry. This image right here, this is now your master blueprint.
Okay, so our character is defined and their geometry is locked in. But what about the world around them? Now we're going to learn how to control the scene and the art style without accidentally messing up the character we just worked so hard to create.
And this slide illustrates a game-changing concept, the priority rule. See, the AI gives the most weight and importance to the first few words it reads in a prompt. So you have to define the world style first. Instead of saying, character in a woodcut city, you say, strictly woodcut engraving style, character walking in a city. This forces the character to conform to the world, not the other way around.
Here's another pro tip. Don't make the AI work harder than it has to. If you've got other people in your scene, just tell the AI they're faceless placeholders or silhouette figures. This simple command stops the AI from wasting its energy hallucinating random, inconsistent faces in the background, which keeps the focus exactly where you want it, on your main character.
We have a perfectly consistent character in a perfectly controlled scene. So what's the final step? Bringing them to life. This is where we transition from the static images we made with Nano Banana Pro to actual video generation using Veo.
Now, the workflow here is very, very specific. First, always use image to video. Don't try to generate a complex character from text alone, it just won't work consistently. Instead, upload that perfect static shot, your seed image, as the source. Then, and this is the most important part, your text prompt should only describe the action and the physics. The AI already has all the character data it needs from the image you gave it.
And you've got to be realistic about what you can create. This brings us to the 8-second rule. Veo generations are best used for short clips. Think of them as reaction shots, maybe a slow blink, a nod, a bit of B-roll footage. You're not trying to generate an entire epic scene in one go.
Here is a perfect example of a great motion prompt. Look closely. We are not describing the character at all. We're describing actions, like blink slowly and look left. And we're describing physics, like making the visor glow brighter. It's like you're a director giving instructions about movement and lighting, not character design.
So let's recap the entire visual engineering workflow one last time. Step 1. Create your immutable seed prompt. Step 2. Generate that reference sheet with Nano Banana Pro to lock in the 3D geometry. Step 3. Apply the priority rule by putting the scene style first in your prompt. Step 4. Use faceless placeholders for any background characters. And finally, Step 5. Animate your perfect static image with Veo, focusing only on action and physics.
And there you have it. You now have the complete blueprint to defeat AI amnesia and to build truly consistent characters for your stories. This workflow takes you from being just a prompter to being a true visual engineer. So the only question left is, what world and what character are you going to build first?